Have you ever wondered why your SQL queries are slow, especially when your table has thousand or million of rows? Well, today I'm going to show you a superpower that can speed your things up like magic. And it is called indexing and optimization in SQL. So let's go. Imagine you are reading a book and you want to find a chapter on Harry Potter. So if there is no index in the book, what will happen? You will flip page by page until you find it. Isn't it right? So it is basically a slow process. But if the book has an index at the end, okay, if the book has an index, you look up Harry Potter, it says page 187 and you jump straight there, which is fast and easy. That's exactly what indexing does in SQL. It helps the database find the rows it needs without scanning the entire table. Now let's take an example from our store management system. So suppose the order table has 1 million rows, okay, and you write this query. Okay, so this query is without indexing. What will happen? SQL checks every row one by one, and which makes it very slow. But if we create the index like this, okay, if we create the index, then what will happen? Then SQL has a shortcut. It can directly jump to rows where customer ID 103. So it is much faster. And you know guys, what's the best part here? You only create the index once and after that SQL automatically uses it. You don't need to write anything special in your queries again and again. Now let's talk about optimization. So it simply means writing smarter and faster SQL queries. Okay, think of it like this. You are cooking. If you cut all the vegetable first, okay, arrange all your spices and keep things ready, your dish comes out perfect and fast, and that's optimization. It means to planning your query so it runs better. Okay, here are a few ways to optimize your SQL. You can use indexes wisely. Okay, avoid select star, only select what you need. Use limit to avoid loading 1 lakh rows. And always check your queries using explain to see what's happening inside. So in short, what benefits we are getting from the optimization and indexing? It increases the speed 10 times to 1000 times on large tables. It reduces the CPU and memory usage. Joins between large tables become quicker. Real-time dashboards and analytics run smoothly. Essential when rows cross 10,000 plus. Okay. Faster apps and websites for the end users. Querying millions of rows becomes easy now. Systems remain fast even with growing data. So these are some benefits. Now let's practice indexing and optimization on MySQL. So I have opened MySQL Workbench, and here through the queries we will see how indexing basically works. So our database that we are using is a store database. So we have to mention it that we are going to use this store database now. Okay, so query number 1 is to create index on foreign key column. Okay, now what the foreign key here is, if we see all our tables, so first one is customer table, then order details, then orders, then products table. Okay, so if we go to this table, which is orders table, here we can see, let me enlarge it. Okay, here we can see we have customer ID, and this customer ID belongs to this table, which is customers table. Okay, its parent table is this customers table. So we can see that this customer ID in this orders table is what? Foreign key, right? So we are going to apply now indexing. We are creating indexing on this column, which is customer ID orders table. So to create index, the syntax is simply to write create index. This is our syntax. Okay, and then we have to give the name of this index. So I'm giving it IDX orders, and I'm giving it as customer ID. Okay, then we have to write on, now we have to write the name of the column on which we want to apply index along with the name of tables. So on orders tables customer ID, because customer ID here is working as foreign key. This is it. Now we need to run it, and after running, the index has been created. Okay, now the second query is to create composite index on order details. After some time, we will see whether index has been created or not. Let's quickly complete this query 2 also, then we will check it. So we have to write here create index idx, okay, order detail product on order details table, order ID column as well as product ID column. So here we are creating composite index. Now let's have an example of composite index. So here you can see index and then order ID and then the product ID. Okay, we want to create the composite index. So what are the possible combinations are here in our tables. Whatever with the existing combinations are there, on that combinations SQL apply the index combinedly. How? See, this index 1 has been given to order ID 101 and 201. Okay, index 2 has been given, this numbering 2 has been given to the combination of 101 order ID and 202. Okay, so these are the possible combination that exists in our data set. It has to be exist. Okay, now numbering 3 has been given to the combination of 102 and 201. Then 102 and 204, it is having the index 4 and so on. So this is called composite index. Now let's run it. And here our composite index also created. Now it's time to check whether our indexes has properly been created or not. So for that we need to write show indexes from the name of the table. We have firstly created an orders table. Okay, so this is it, and now let's run it. So here you can see that key name is written, and here it is written primary and index order customer ID. This index is what we have created just now. Okay, and this primary means it is a primary key. When we declare any column as primary key, then SQL automatically generate index on that. Okay, and this is the index that is created by us. Okay, so these are the two indexes in orders table. Right, now let's do our query number 3, and it is a query with optimized join. Okay, and here I am writing one code, and this code is select name of the customer from customers table and order ID from orders table, from orders table. Now all these data exist where? From customers table C. Now join it with the orders table O. On what basis? Where customers table customer ID equals orders table customer ID, where city equals Mumbai. Now see guys, what is basically happening here. So we have used this filtration Mumbai, and order ID and customer ID are indexed here, right? So what is happening behind the scene is that now optimizer can jump straight to each Mumbai customer's order. Okay, optimizer can jump straight to each Mumbai customer's order instead of scanning the full table. Okay, this is the benefit of creating index. Now come to our query number 4, and it says to get the query using index on filtered column. So here I am writing the query firstly. It is create index idx product category. Okay, this is the name of our index on product tables category. Okay, and now we are selecting all columns from product where category equals electronics. Now firstly let's run it, then I will explain. Okay, here it is products. Fine. Okay, so what is happening here, guys, if we haven't created this index, okay, if we haven't created this index, then what happened? Then SQL has to scan every single row in the table. Suppose there are 50,000 rows total in the table, okay, 50,000 rows, and only 100 rows are of electronics category. Then what is happening? If we will not create the index, then what will happen? SQL will scan every single row. It's very much time taking. Okay, so the solution is that we have created the index. Okay, now we are giving SQL a search shortcut. Basically, it is a search shortcut. Now it doesn't scan the whole table, it jumps straight, okay, to the where? To the electronics section and pull those rows only. So it is a very quicker process now. We can obtain the result in very less time. Okay, so this is the use of indexing. Now come to the query number 5th, and it says using index in data filter. Okay, so firstly let me write the code, and it is create index, and the name of index I am giving here is idx orders order date. Okay, on orders tables order date column. Then our query is to select a star from orders where order date is greater than or equal to some specific date. Let's take it 2024. Let's take some date from the okay, I'm taking this date 2024 March 15 to 2024 March and 15. Okay, of this date we want to extract the data. So first of all we are creating the index here. Now after creation we are running this code as well. So we get the result in a very less time. How? Because instead of scanning the whole table, SQL quickly jumps onto where? Onto the this date, because now it is having index. Okay, we added an index, but how do we know if it's really working? So let me show you how to check that with one powerful SQL command which is called explain. Okay, so let's go. Okay, I'm going to write, so firstly let me write it, that explain usage. This will be our 6th query. Okay. Now I'm going to write one code which is select star from orders where customer ID equals 103. Now we are going to use the same code with the explain. So for that we need to write explain here. Okay, now let's run it. Okay, here is the customer ID. Now let's run it again, and this is the result that we get. It looks confusing, don't worry, I will explain it one by one, line by line. So basically the first one is select type. Okay, select type means here it is written simple, so it means it is just a basic select. Okay, it is just a basic select, there is like no join or subqueries. Okay, then second column is about the tables, and this table have the data which is called value. It means this query reads from the orders table. Okay, fourth column is type, and under this it is written ref, means this is good and your query is using an index to find the rows faster. Okay, now the another column is possible keys. It is simply you can see it is a guide by the SQL that it is telling us that you can use this index. And now this key, it means what? We have created successfully this index. So here the name of this index is mentioned, it means we have created it successfully. Now the next one is key length 5. It means it's using a 5-byte key, okay, for an integer type. It is basically a type ID. Now then ref, again it is written constant. It means it is filtering the data based on a fixed value. Okay, constant means what? It is filtering the data based on a fixed value, and here that value is 103. Okay, then row 1 means what? It means SQL estimates it will only need to look at one row super fast, because customer ID exists only in the one row. That's why it is written here. Now what is the meaning of the filtered 100? So it means that one row fully matches the condition, 100% condition is being matched. then extra, and it is written null here. It means nothing extra is happening. This is it, what we have explained. Okay, no extra function we are using here. So these are the queries related to the index, how to create index, how to check the index whether it's been created or not, and how to use the explain to get the details of our indexed row or column. Okay. So this is it for this video, guys. See you soon with the new topic and new project. Till then, take care, keep practicing. Bye bye.